Today's lesson is on the standard form of the quadratic equation. Remember that is y equals ax squared plus bx plus c. There's two big things that we need to get from the quadratic function. One of those is the vertex, which we're going to work with today, and the other are the x-intercepts, which will be coming up in a couple sections. So how are we going to find the vertex when it's not in vertex form? We could put it in vertex form, but again, that's still a couple chapters away. Well, I should say a couple sections away, not chapters. But there's a much easier way, and it looks like this. We have a vertex is negative b over 2a. That's your x value, or your input. And then, of course, we want to, since we're, math people, we want to make it look really hard. So we write it like this. F of negative b over 2a. And all that is saying is that, hey, what is the function if I put negative b over 2a into that function? So let me spell it out a little bit easier here. This is called your x value, but we've also called it domain, but we've also called it the input value. This is your y value, or your range, but we've also called it the output. So if you can figure out what the input is, guess what you should do? Put it in, all right? And you'll notice that here's the B that's on the top, here's the A that's on the bottom. So all you have to do is change the sign of B, multiply the A by 2, and simplify the fraction, of course. That's your x value. Take that x value, put it into the equation to get your y value. And hey, you've got a vertex. Let's go ahead and give one a try. So we have the function of y equals x squared plus 2x plus 3. And I want to get the vertex of this function. So first thing you need to do is be able to identify the a, the b, and the c. The a is the number in front of x squared, which is 1. The b is the number in front of x, which is 2. And c is the constant, which is 3. So there we have our A, B, and C. Now I know this is saying something about the axis of symmetry, which is great, but really all I want to find is the x value of my vertex. And I got to do two things and then simplify a fraction. The two things are change the sign of B. Well, B is a 2, so when I change the sign, it becomes a negative 2, right? I'm going to multiply the A by 2, like that, and then I'm going to simplify that fraction. So my x value of the vertex is negative 1. Remember, x value is also your input value. So if I take that and put it in to my equation, I get a y value, or an output, of 2. And guess what I have? I have a vertex of negative 1 comma 2. Now I will tell you that I'm not a big fan of graphing these by hand, but I will have you graph them once in a while. The two things that you need to graph are the vertex, obviously, and this is a terrible way to say it, the slope. This is not a line, and I'm putting the quotes around slope because that's what I did with the absolute value, but absolute value kind of was line, so we're going to double quote this because it's not really a slope. If your denominator of your slope is a 1, then your numerator tells you how many you have to go up, and you're going to go over 1. So as long as it's a integer, it's pretty easy. And you only do it one time, and then you make a little u, and you have a sketch of your graph. It won't be perfect, but it'll get by. All right, so if we can get the vertex, then we can put that back into vertex form, which is somewhat helpful. Okay, so there's two things you need to put it into vertex form, and obviously that's the vertex and the slope. The slope is a, and if you remember, a is the same in vertex form as it is in standard form. So looking at this function, I already know what the a is. I know the a is going to be 2. So all I have to do is the vertex. And I do the vertex by doing the things. Let's identify the A, the B, and the C. All right, so we're going to identify the A, B, and C. right? So 2 is my A, 10 is my B, 7 is my C. Then I'm going to change to get my X coordinate of the vertex. I'm going to change the B. Well, it's positive 10, so I'm going to change it to negative 10. I'm going to multiply the 2 by a 2, make the fraction, and then I'm going to simplify the fraction. And I'm not a huge fan of negative 2 over 5 for theoretical math because we should be able to work with fractions. But seeing as how it is an ending decimal, I'll let it slide this time. All right, so we got negative 2.5 as our X value or our input value. And so what should we do with an input? Well, obviously we should put it in. So we put it into the function, do a little bit algebraic magic, and we get negative 5.5. Now these two values, I would rather see negative 5 halves, comma, negative 11 halves. That makes me a lot happier than negative 2.5 and negative 5.5, but you get the picture. All right, so we have our two numbers that we need to put in, and we have our A, our slope with double quotes, and now we just gotta put those into this formula here. Remember, when you put the H value or the X value into the parentheses, you gotta change its sign. And there we have the vertex form of the standard form that you see up at the top. All right, so let's finish this up with a word problem. So we have a bridge in West Virginia that's the largest steel single arch bridge that can be modeled with the function given there, where X and Y are both measured in feet. And I want to know how high above the river is the arch, and then how long the section of the bridge that's above the arch. So just for number sense, when I'm looking at this picture, I say, well, my height, my Y value, has got to be bigger than 516 because they're telling me it's 516 to the bottom of the arch, and I want to know how far it is to the top of the arch. By the way, the top of the arch would be the vertex. Do I have enough information to figure out the vertex here? Yes, I do. Some of you might be saying, oh, it's in decimals. Remember, this question is not a theoretical math question. This is a real-world math question, which means decimals make more sense than fractions. So sometimes I like fractions, sometimes I don't. I know, it's crazy. All right, so we have an A of negative 0.000498. We have a B of 8.847. We should be able to put that into our vertex formula, the negative B over 2A, and get out a X value. So let's go ahead and do that. So here's our arch that I plotted on a graph paper. Don't pay attention to those numbers because they already gave you the answer. Sorry about that. So let's go ahead and put those numbers that we had in the last one into our vertex formula. So I changed the sign of B, I multiplied the denominator by 2, and then I rounded it to 850. You could round it to a tens place or a hundreds place. It doesn't really matter. So it's up to you if it's not given to you in the problem. So that's my input, right? So I take my input and I put it in, and I get 360. That's where that 850 comma 360 is. So the height is your Y value. I get 360 feet. But remember, we said that it should be more than 516. Well, that's because I've got to add it to the 516 that was already there. So this arch, the top of the arch, is about 876 feet above the river. And then the X value is the length of the bridge. Well, it's half of the length of the bridge because the vertex is in the middle. So we take the 850 and we double it, and we get 1,700 feet for the length of the bridge that's above the arch. And that finishes it up.